Hi, everyone. My name is Shivam Srivastava, and I'll be presenting from Cal State Long Beach and Dr. Tian's Surface and Interface Lab Group on the green synthesis of iron MyL88B for drug delivery. So the significance of this project is that cardiovascular disease has become the leading cause of death in the United States of America. So typically, drug-eluting stents have been used to perform balloon angioplasties, and that is in order to prevent plaque blockages while simultaneously releasing drugs that help with cell proliferation. However, drug-eluting stents have a polymer coating, and in times, pieces of this polymer coating have remained on the stent and have led to thrombosis. So in this lab, we have been researching methods to use a more biodegradable and non-toxic option, and that would be an iron-containing metal organic framework or an iron MOF. So the specific MOF that we are studying in this experiment would be MyL88B, and it's a porous crystal that is composed of metal clusters and organic linkers. So the composition of MyL88B, it contributes largely to the surface area and great pore size. That makes it a good candidate for drug elution. So in this study, we're looking to synthesize MyL88B using a greener method. So one method that's more environmentally conscious and cost effective. So it is really important to look into greener synthesis as the future of iron MOF entails large scale productions where the effect on the environment and costs are going to be critical factors. So generally, we have been synthesizing MyL88B using a soluble thermal method using DMF or a dimethylformamide as a solvent. So the use of DMF is especially in bulk. It poses a huge threat to our environment, especially due to the toxicity of the solvent. So for this reason, we're examining new synthesis techniques that use a hydrothermal method or a room temperature synthesis method that both do not use non-toxic solvents. So to begin in our lab, we have used two preparation procedures. The first one being a dropwise preparation and the second one being a hydrothermal preparation. The first method used two solutions. One was added dropwise into the other, and it was not yielding the best results. It was kept under stirring for 18 hours and used compounds such as terephthalic acid, iron chloride hexahydrate, water, and sodium hydroxide. So after each round of centrifugation, it was found that there was no pellet formed, thus there was no MOF formed. So the dropwise preparation procedure was not the best. We also used a hydrothermal preparation method that used elevated temperatures and water as a solvent. So we dissolved 2.6 or 2.7 grams of iron chloride hexahydrate into water. And then once it was fully dissolved, we combined it with acetic acid and terephthalic acid. After the combination, we put it under stirring for about 24 hours. And then we baked it in the oven at 110 degrees Celsius. So after 3 cycles of centrifugation, we were promised with better results. And we were able to have a pellet formed after centrifugation. From this pellet, we ran IR in order to confirm the character of the MOF we produced. And the results were promising, except they did not align completely with the soluble thermal method that we usually use to synthesize MyL88B. So as one can tell, the peaks look very similar in their alignment, but they're not exact as they should be. So it promises to be a good method using the hydrothermal preparation, but more studies and adjustments still need to be made to confirm it. So it is possible to create MyL88B using a green synthesis method, but we will need to do further studies on it. Some methods that we could hopefully use to better our procedures and hopefully yield better results would be to maybe use an autoclave or another procedure of dry ball milling in order to synthesize MyL88B. Thank you guys so much.